So once again, welcome to this online class. So today's topic is virtual work. Sometimes it happens that system is in equilibrium, then we say that there is no work done. But when we apply force on the system, there may be very small displacement, or you can say there may be virtual displacement, and the work done by that virtual displacement is virtual work. So force applied with the small displacement gives virtual work. Now, principle of virtual work: the necessary and sufficient condition that a particle acted upon by a number of coplanar forces. Coplanar means the forces that act on a same plane be in equilibrium is that sum of virtual works done by the forces in small displacements consistent with the geometrical conditions of the system is zero. So let us take this system. Here F1, F2, F3 are the forces, and for F1, X1, Y1 is the component of this force along XY axis. In same way, X2, Y2 is the component of the force F2 along XY axis. And the virtual work done by the forces F1, F2, Fn are, if the force is acting at the point alpha beta, point having coordinate alpha beta, then corresponding to this, the component of force F1 will be xi, x1i plus y1j, and this point is alpha I plus beta j. So corresponding to this, work done will be F1 dot R. So corresponding to this, virtual work done will be alpha x1 plus beta y1. In same way, we have virtual work done by F2, F3, and so on. Now, since the system is in equilibrium, the sum of all these forces, all these work done will be zero. So we have this thing. And from this, we have alpha sigma x plus beta sigma y equal to 0. Now, from the theory of force, the sum of this, the linear combination of these two forces will be 0 only if sigma x is 0 and sigma y is 0. And now, let the new position of O dash is alpha dash beta. Suppose इस पॉइंट को हमने नई पोजीशन पे शिफ्ट कर दिया है, हॉरिजॉन्टली शिफ्ट किया है, so that the vertical component, that is beta, remains the same, and जो x coordinate है इस component का, इस point का, that becomes alpha dash. So in new position we have alpha dash beta dash is new coordinates of the point O dash, and corresponding to this point we get the equation alpha dash sigma x plus beta sigma y equal to 0. So subtraction these two, equation 1 and 2, we get alpha minus alpha dash sigma x equal to 0. Since alpha minus alpha dash is not equal to 0, this implies sigma x equal to 0. And similarly, we can prove that sigma y equal to 0. So this proves the principle of virtual work. If system forces are in equilibrium, then the sum of virtual work done is 0. So we have proved first that if first we have proved that if sigma x sigma y equal to 0, then we have this alpha sigma x plus beta sigma y equal to 0. And secondly, we have proved that if sum of virtual work is 0, then corresponding to that, we have sigma x and sigma y equal to 0. Now, similarly, we can prove the virtual work done by a rigid body. If a system of coplanar forces acting upon by a rigid body and keeping the body in equilibrium, and if the body be given a slight virtual displacement consistent with the geometrical conditions of the system, then the algebraic sum of the virtual works done by the forces is 0. Conversely, if the algebraic sum is 0, then forces will be in equilibrium. So here, let us consider force F1 acting at a point x1, y1 with polar coordinates r1, θ1. इस point A1 के कार्टेशियन कोऑर्डिनेट x1, y1 है और पोलर कोऑर्डिनेट्स है r1, θ1. In that case, we have x1 equal to r1 cos θ1 and y1 equal to r1 sin θ1. Now, giving slight displacement to the body, the A1 takes the position A1 dash, this one, and it happens by rotating the body through a small angle θ1 and then moving it parallel to the axis through the small distances delta A, delta B as shown in the figure, and let A1 dash has coordinates x1 dash, y1 dash. In इस point A1 को पहले हमने डेल्टा थीटा एंगल रोटेट किया, उसके बाद हॉरिजॉन्टल डायरेक्शन में डेल्टा ए डिस्टेंस मूव किया है एंड देन इन वर्टिकल डायरेक्शन डेल्टा बी डिस्टेंस मूव किया, देन फाइनली वी रीच टू द पोजीशन A1 dash. Then from this figure, it is clear that x1 dash will be OL plus B1 C1. And from this triangle B1 OL, OB1 के coordinate, OB1 is R1 और इसी corresponding जो थीटा है that is θ1 plus delta θ1. So OL from the triangle B1 OL, the value of OL will be R1 cos θ1 plus delta θ1 and plus B1 C1, this is delta A. Now expanding this and neglecting the small terms or taking, since the value of delta θ1 is very small, so we can assume it as 10 to 0. So in that case, cos delta θ1 will be 1 and sin delta θ1 will be delta θ1. It means cos delta theta और sin delta theta के एक्सपेंशन में जो हायर ऑर्डर डेरिवेटिव्स है उनको हमने यहाँ पे नेग्लेक्ट कर दिया है. So in this case, cos delta θ1 will be 1 and sin delta θ1 will be delta θ1. Using this, we get this expression. Now finally, R1 cos θ1 is x1. R1 sin θ1 is y1. So we get x1 dash equal to x1 minus delta θ1 y1 plus delta A. In the same way, we have y1 dash equal to y1 dash. This, the vertical distance of this point, this will be B1L plus A1 dash C1. So B1L is R1 sin θ1 plus delta θ1 और A1 dash C1 is delta B. इसी टाइप से यहाँ पे sin θ1 plus delta θ1 को sin A plus B से एक्सपेंड कर दिया and using cos delta θ1 equal to 1 and sin delta θ1 equal to delta θ1. So finally we get y1 dash is given by this equation number 3. Now displacement of A1 along x-axis is x1 dash minus x1. So this is this one. In same way, displacement of A1 along y-axis is y1 dash minus y1. So this is this one. Now let x1 and y1 are the component of the forces along the axis. Then the virtual work done by the force F1 will be force multiplied by displacement along the axis. So this is equal to the sum of virtual work done by the components x1, y1. So x1 multiplied by displacement of A1 along x-axis plus y1 multiplied by displacement along y-axis. So putting the values, finally we get this equation number 6. Similarly, we can find the virtual work done by the other forces acting at different points of the body. This work done is by the force F1 acting at the point A1. So in same way, we have the force at other points, and now the algebraic sum of the virtual work done by the system of forces acting upon the rigid body. This will be sigma of summation of these all forces. So sigma x1 delta A plus sigma y1 delta B plus sigma x1 y1 minus y1 x1 delta theta 1. So we can write this equation in this form. Now, if the system of forces acting upon the rigid body is in equilibrium, system of forces in equilibrium, it means the resultant of all force will be 0. So in that case, we have sigma x1 equal to 0, sigma y1 equal to 0, and sigma x1 y1 minus y1 x1 is equal to 0. Hence, the algebraic, putting these values here, we can see that the algebraic sum of the virtual work done by the system of coplanar forces is 0. Conversely, if algebraic sum of virtual done by the system of coplanar force is 0, then we have this equal to 0. Now, if we choose a displacement in which body moves only along x-axis, means displacement is only along parallel to x-axis. In that case, delta B will be 0 and delta theta 1 is 0. So now putting these values, we get sigma x1 delta A equal to 0, but sigma delta A is not equal to 0 since we are taking displacement along parallel axis. So this is not equal to 0, and this implies sigma x1 equal to 0. Again, if we take displacement in which body moves only a small displacement delta B parallel to y-axis, in that case delta A is 0, delta theta 1 is 0, and so we have sigma y1 equal to 0. Finally, let us choose a displacement in which body rotates through a small angular displacement delta theta 1. Then we have, it means in this case, displacement is only angular displacement. So in that case, delta A and delta B is 0 and delta theta 1 is not equal to 0. So finally we get this thing. So combining this result, we get sigma x1 equal to 0, sigma y1 equal to 0, and sigma this equal to 0. It means if the algebraic sum of virtual work is 0, then the forces are in equilibrium. Now, in framing the equation of virtual work, we can omit some forces. So there are these type of forces which we can omit. We can neglect these type of forces. First force is tension of an inextensible string. So let T be a tension in the string and it is displaced to A dash B dash. AB is initial position of the string. और इस AB को हमने डिस्प्लेस करके A डैश B डैश पोजीशन में ले आए, ठीक है, यानी कि एंगुलर डिस्प्लेसमेंट यहाँ पे थीटा एंगल का हुआ है और बाकी A पॉइंट A डैश पे पहुंच गया है एंड B पॉइंट इज डिस्प्लेस टू B डैश. So it is displaced to A dash B dash, making an angle theta with AB, where theta being very small, as shown in figure. We draw perpendicular from A dash and B dash. Now tension T in the string AB is equivalent to force T at A along AB and force T at B along BA. इस स्ट्रिंग में जो टेंशन है इक्विलिब्रियम पोजीशंस पे स्ट्रिंग में जो भी टेंशन होगा दैट विल बी इक्वल एंड इन अपोजिट डायरेक्शन. तो जो ये टी फोर्स है दिस इज अलोंग ए बी डायरेक्शन, और ये राइट हैंड साइड में जो टी फोर्स है दिस इज अलोंग बी ए डायरेक्शन. नाउ द वर्चुअल वर्क डन बाय द टेंशन व्हेन दिस string is displaced from A B to A dash B dash, it will be the virtual sum of virtual work done by tension T at the point A and tension T at the point B. So this will be T into AL. This displacement is AL plus T into BM. This displacement is BM. Now AL is AB minus LB and BL is LM minus LB. So it becomes T into AB minus LM, and LM is equal to A dash B dash. Sorry, LM is A dash N. LM is A dash N, and from this triangle, in triangle B dash A dash N, from this triangle we can write A dash N equal to A dash B dash cos theta. So this is T into AB 1 minus cos theta, and on expanding this we get this thing. And since we are taking very small displacement, so we can neglect higher powers of theta. So from this we get 1 minus 1, that becomes 0. So the virtual work done by the tension when the string of an inextensible string is 0. In same way, we can prove that the thrust in a light rod is also 0. इस केस में यहाँ पर जो थ्रस्ट है उसकी डायरेक्शन ये अपोजिट हो जाएगी. स्ट्रिंग में ये जो फोर्सेस हैं ये इनवर्ड डायरेक्शन में रहेंगे और थ्रस्ट में ये फोर्सेस आउटवर्ड डायरेक्शन में हो जाएंगे. बाकी प्रूफ आपका सेम रहेगा. इन द लाइट रॉड द डायरेक्शन ऑफ द टेंशन विल बी रिवर्स्ड as in the case of the tension of an inextensible string. So the proof is similar to that of an inextensible string. In same way, the reaction of any smooth surface with which the body is in contact is 0. The mutual pressure between two bodies in contact, we can omit this force also. The reaction at the fixed point or a fixed axis about which the body rotates, it is also 0. And the reaction at a point of contact with fixed surface on which the body rolls without sliding. So these are 6 forces we can omit or we can neglect during framing of the equation of virtual work. Now next is tension of a string or thrust in a rod. Here we have taken inextensible string. Inextensible string का मतलब क्या है कि जिसमें प्रेशर पड़ने पे कोई लेंथ में चेंज नहीं हो रहा है. बट इफ देयर इज लिटिल चेंज इन द स्ट्रिंग, देखिए अगर स्ट्रिंग खिंच रही है उसकी लेंथ में चेंज हो रहा है, then we have tension of a string. So जैसे अभी यहाँ पर प्रूफ किया है उसी टाइप से हम we can also obtain the tension of a string. Let T be a tension in the string AB as shown in above figure, and now replacing the tension by a force T at A along AB and a force T at B along BA. So finally we get T AB minus A dash B dash cos theta. And since theta is very small, so we can neglect higher powers of theta. So cos theta is equivalent to 1. So T AB minus A dash B dash. Now if AB is L, then A dash B dash will be L plus delta L, because here we are taking extensible string. इसके पहले जो भी स्ट्रिंग थी दैट वाज इनएक्सटेंसिबल स्ट्रिंग, यानी उसमें लेंथ पे कोई भी प्रभाव नहीं पड़ रहा था, प्रेशर या फोर्स अप्लाई करने पर भी स्ट्रिंग में कोई भी खिंचाव नहीं आ रहा था. बट इन दिस केस देयर इज स्मॉल चेंज इन लेंथ ऑफ द स्ट्रिंग. इस वजह से यहाँ पे AB, if AB is L, then A dash B dash will be delta L. So in that case, we get minus T delta L. This is the work done by a tension T in string. And similarly, in case of rod, process पूरा same रहेगा, but direction will be outward direction. जैसे अभी हमने बताया स्ट्रिंग में इनवर्ड डायरेक्शन में फोर्स लगेगा और रॉड में आउटवर्ड डायरेक्शन में. तो in that case, we get T delta L. So you should learn that the tension of a string is minus T delta L, and tension of the thrust in a rod is T delta L. Now let us see one example on this. 5 lateless rods of equal length are joined together so as to form a rhombus ABCD with one diagonal BD. Here A, B, C, D and BD are 5 rods, and if a weight W is attached to C, the system is suspended from A so that there is a thrust in BD equal to W upon root 3. So let 5 rods form a rhombus and diagonal BD, 4 sides of a rhombus and the diagonal BD. Since the system is suspended from A, then there is a weight W attached to C, and AC will be vertical and consequently BD horizontal. Now suppose the rod AB or AC makes an angle theta with the horizontal through the point A. यहाँ पे ये angle theta है, तो alternate angle के through this angle is also theta. Now this system is in equilibrium. Now let we give a small symmetrical displacement such that theta changes to theta plus delta theta. Now, since A is fixed point, we measure the depth of C from the point of application of W below A. A fixed point लेंगे और जितनी भी चीजें हम मेजर करेंगे सारी इस fixed point से ही मेजर करेंगे. So the length of rod is A. Now if we take this triangle AOB, and we know that the diagonals of rhombus intersect each other at 90 degree. So from this triangle in triangle AOB, we can see that AO is A sin theta and BO is A cos theta. So इसके through AC will be 2A sin theta and BD will be 2A cos theta. Now AC is 2A sin theta, where A is length of rod, hence the work done by the weight W during small displacement will be this one. ये weight यहाँ पर अटैच किया गया है, तो इस पॉइंट के करस्पॉन्डिंग पॉइंट C के करस्पॉन्डिंग जो वर्क डन होगा इस वेट की वजह से, दैट विल बी वेट मल्टीप्लाइड बाय डिस्प्लेसमेंट in AC. So corresponding to this, we have work done during small displacement is W del 2A sine theta, and work done by thrust of this rod. Thrust of this rod will be T delta length of the rod. So the work done by the thrust is T delta 2A cos theta. Now, by the principle of virtual work done, total virtual work done is 0. So finally, we get T delta 2A cos theta plus W delta 2A sin theta. On differentiating this, we get T into 2A minus sin theta plus W into 2A cos theta multiplied by delta theta. Now, since we are giving the small displacement delta theta, so in this case, delta theta will not be 0. So this is 0. And on simplifying this, we get T equal to W cos theta, cot theta, sorry. Now in triangle AOB, cot theta will be BO upon AO. In this one. In the case of equilibrium, this AB is A and BO is A by 2. And using Pythagoras theorem, we can obtain AO. AO will be under root of A square minus A square by 4. So, cot theta will be A by 2 upon under root of A square minus A square by 4. And this is 1 by root 3. So, finally, we get T equal to W upon root 3. Let us see one more example. A quadrilateral ABCD formed of 4 uniform rods freely joined to form to each other at their end. The rods AB and AD being equal, and also rod BC and CD is freely suspended from the joint A. A string joins A to C is such that triangle ABC is a right triangle, and applying the force, the principle of virtual work, we have to show that the tension of the string is given by this expression, where W is the weight of upper rod and W dash of the lower rod, and 2 theta is equal to the angle BAD. So in this case, we have this thing, and it is given that AB equal to AD, और ये जो rods हैं, rods का जो weight है वो मिड पॉइंट पे टेक कर। इसके पहले वाले क्वेश्चन में हमने रॉड्स का वेट नहीं कंसीडर किया था क्योंकि वहां पर वेटलेस रॉड्स गिवन थी, ठीक है। यहाँ पे रॉड का वेट गिवन है, यहाँ पे देखिए here we have 5 वेटलेस रॉड्स ऑफ इक्वल लेंथ। तो इस वजह से इन रॉड्स का वेट यहाँ पे नहीं कंसीडर किया था, केवल वेट ये W कंसीडर किया गया था जो अलग से अटैच किया गया। लेकिन यहाँ पर रॉड का वेट भी गिवन है, हैवी रॉड्स गिवन है। सो AB equal to AD given है, and angle B is 90 degree. This angle B is 90 degree. This is given. Now suppose angle CAB. Suppose this angle is theta. This angle is 90 degree. Then this angle will be 90 minus theta. Angle BCA 90 minus theta. तो angle BCA को हम यहाँ पे phi suppose कर ले रहे हैं, ठीक है। Now AC will be, अगर यहाँ से इसको ऐसे ब्रेक कर BD को हम ज्वाइन कर लें, then AC is perpendicular to BD. इस BD को अगर हम ज्वाइन कर लें तो AC की जो लेंथ होगी, now AC will be AB cos theta, यहाँ पे if we join BD, this BD intersects AC at the point O, जैसे यहाँ पे अभी किया था। इस केस में ये रॉड्स सारी इक्वल गिवन है, लेकिन यहाँ पर ये रॉड्स इक्वल नहीं गिवन है। ऊपर की 2 रॉड्स इक्वल है और नीचे की 2 रॉड्स इक्वल है। ठीक है, ये एंगल थीटा है और ये एंगल 90 माइनस थीटा इस टाइप से है। तो ये AC इक्वल टू क्या हो जाएगा, AO प्लस OC हो जाएगा, और AO इक्वल टू यहाँ से AB cos थीटा होगा, और OC इक्वल टू यहाँ से हो जाएगा BC cos फाई। वही चीज यहाँ पर है, ये AC will be AB cos theta plus BC cos phi. So suppose AB equal to 2A equal to AD and BC equal to 2B equal to CD. So we have AC equal to 2A cos theta plus 2B cos phi. Now the depth of the center of gravity of AB or AD. अब जो भी वेट है, वेट की करस्पॉन्डिंग जो भी वर्चुअल वर्क हो रहा है, वेट यानी कि फोर्स। तो अब यहाँ पर देखिए, ये 2W फोर्स एक्ट कर रहा है, और इस 2W फोर्स का जो डिस्टेंस है पॉइंट ए से, दैट इज दिस वन, एंड दिस इज 1 4 दिस वन, इसके मिड पॉइंट पे एक्ट कर रहा है। सो दिस डिस्टेंस विल बी A cos theta. So the depth of center of gravity of AB or AD will be A cos theta. इसी टाइप से depth of center of gravity of BC और CD, यहाँ पर ये this will be there is mistake is here. BC और CD की जो सेंटर ऑफ ग्रेविटी है, ये इस पॉइंट पे एक्ट करेगी। तो इस पॉइंट का, यहाँ पर इस पॉइंट का पॉइंट A से डिस्टेंस हम कंसीडर करेंगे। पॉइंट A से ये W, जो लोअर W इनको ज्वाइन करेंगे, और जहाँ पर ये लाइन AC को ज्वाइन करेगी, इस पॉइंट का डिस्टेंस A से लेंगे, देन दिस विल बी this one 2A cos theta plus B cos phi, and the equation of virtual work will be, equation of virtual work क्या होगी, this will be, इस AC को एक स्ट्रिंग से अटैच किया गया है, इसकी करस्पॉन्डिंग T delta AC. So this equation is not required. We have to consider this equation T delta 2A cos theta plus 2B cos phi corresponding to tension T delta AC plus 2W delta is 2W weight का point A से distance, this one A cos theta, और 2W dash weight का distance point A से, that is be delta 2A cos theta plus B cos phi equal to 0. इसको सिंप्लीफाई करेंगे, and after simplification we get this equation. Now but theta and phi are connected by the relation A sin theta equal to B sin phi. अगर इस ट्रायंगल में हम ये BD को जो हम ज्वाइन कर रहे हैं, तो ये BO की वैल्यू अपर ट्रायंगल से ऑब्टेन करेंगे तो A cos थीटा आएगी, और लोअर ट्रायंगल से ऑब्टेन करेंगे तो B sin phi आएगी। So here we have A sin theta equal to B sin phi. This gives A cos theta delta theta equal to B cos phi delta phi, and delta phi equal to A cos theta upon B cos phi delta theta। इस इक्वेशन में पुट कर देंगे और इसको सिंप्लीफाई करेंगे, एंड ऑन सिंप्लीफिकेशन we get this equation. So next, one more example. 4 equal heavy rods are freely joined so as to form rhombus, which is freely suspended by an angular point, and the middle point of 2 upper rods are connected by a light rod. अब इस केस में 4 heavy rods consider की गई हैं और जो अपर रॉड्स हैं इनके मिड पॉइंट को स्ट्रिंग से अटैच किया गया। तो 4 हेवी रॉड्स के करस्पॉन्डिंग वेट एक्ट करेगा, नो गिविंग स्लाइड डिस्प्लेसमेंट टू द सिस्टम सच दैट अल्फा बिकम्स अल्फा प्लस डेल्टा अल्फा वर्क डन बाय द वेट 4W। अच्छा ये अच्छा, क्योंकि यहाँ पे रोम्बस है, रोम्बस में 4 इक्वल रॉड्स हैं, तो इस रोम्बस का जो कि 4 रॉड्स का जो वेट होगा 4W, वो इसकी सेंटर ऑफ ग्रेविटी यानी डायगोनल पॉइंट पे एक्ट करेगा, डायगोनल्स के इंटरसेक्शन पॉइंट पे एक्ट करेगा। सो द वर्क डन बाय द वेट विल बी 4W डेल्टा AG, and from this triangle, in triangle ABG, AG is 2A cos alpha. And for this string, the length of this string LM will be twice of this. In this small triangle, the length of base is A sin alpha, this one. This will be A sin alpha. So LM will be 2A sin alpha. So virtual work done by the system will be 4A delta 2A cos alpha plus T delta 2A sin alpha equal to 0. So on simplifying this, we get this equation, but delta alpha is not equal to 0. So on arranging the term, we get T equal to 4W tan alpha. इसी टाइप से आगे ये 4 and 5th examples भी हैं. So you can try this. Let's see one more example. Example number 6. 6 equal rods of weight W are placed to form a regular hexagon such that upper rod is fixed. This upper rod is fixed. तो जो fixed point है, fixed चीज है, उससे ही सारे distance हम measure करेंगे. And the middle point of the hanging rod are tied with the string, so that each string has tension 3 times the weight of one rod. तो 6 इक्वल रॉड्स हैं और ये 2 रॉड्स को के मिड पॉइंट्स को स्ट्रिंग से टाइट किया गया है. इस हेक्सागन का टोटल जो वेट है 6W, ये इसकी सेंटर ऑफ ग्रेविटी यानी G पॉइंट पे कर रहा है. तो दिस डिस्टेंस इस kg, और चूंकि यहाँ पे रॉड ली गई है तो इसकी करस्पॉन्डिंग वर्क डन क्या हो जाएगा, -T1 डेल्टा लेंथ ऑफ द रॉड minus T2 delta length of rod ML, and plus 6W delta kg. So this is minus T1 rod की लेंथ अगर हम यहाँ पे x सपोज कर लें, so delta x minus T2 delta x plus 6W, this is also delta x. You can see from here that this kg is equal to this Lm. So from this we have T1 plus T2 equal to 6W. Now the middle, now we have to find that each string has tension 3 times of the weight of the rod. Now taking the moment about G, we have T1D equal to T2D, क्योंकि यहाँ पे rods सेम टाइप की ली गई हैं, उनका जो मोमेंट है उसका इन दोनों रॉड्स का मोमेंट इस पॉइंट जी के अबाउट अगर हम कंसीडर करेंगे तो इक्वल आएगा, सिंस सिस्टम इज इन इक्विलिब्रियम. So for this we have T1 into D equal to T2 into D, and this implies T1 equal to T2, and since T1 plus T2 equal to 6W, so finally we get T1 T2 equal to 3 times the weight of one rod. So in this way we can solve examples, questions on the virtual works. So just go through this video and like and subscribe this lecture. Thank you.